So we are welcome to this session. We're going to talk about building a portable platform. We're going to talk about what a platform is, what that means, and how you can build one with OpenShift, which actually leads me to a first question. How many people here have heard or have used OpenShift? Okay. And what about ROSA? Do people know what ROSA is? So I got one hand there. ROSA is that's the nickname, I guess, for Red Hat OpenShift on AWS. It's a first class service up there. You can go to aws.amazon.com/ROSA. I put a link at the end here. It's a great way to skip some of the initial provisioning that you got to do with OpenShift, especially if you're running it on-prem, but even if you're running it in AWS. So yeah, it actually provides, that's what we're going to discuss, it provides a great way to build a lot of stuff on top of it. So yeah, I kind of glanced over, but I work for Red Hat. I'm a solutions architect. I support customers in the Chicago area. I'm also really involved with CNCF work. I'm a leader in the tag app delivery, where we review projects, we write white papers, and we try to support end users in delivering workloads and applications on cloud native platforms. A lot Kubernetes, but also AWS, that counts. And I also wanted to mention this. We just had our first event on Monday since post-pandemic. Our first in-person event, the Chicago CNCF group. We're having a planning meeting a week from today, actually, if you want to join it. We hope to have an event in August, an in-person event. We want to run some Kubernetes community days. CNCF is pretty supportive of that. So join us. Check out the site there. Join the site. You get our emails. Come to our events. I figure it's a good place. This is an AWS community. I'm talking with Margaret about how we can work together. Okay, now let's jump into the fun stuff. So what is a platform? In Tag App Delivery, a couple of years ago, actually, we formed a group called Cooperative Delivery. That was what we called it to begin with. The goal of the group was to help our users deliver their applications and their infrastructure. Like, there had been this movement around GitOps, and we can get out a Kubernetes cluster, or we can get out databases, but how do we actually get an app and infrastructure coordinated? So I get the database and the cluster that I need together with the Spring Boot app or whatever that I need on top of it. And we pursued that group. We formed a couple of years ago, but then we realized the platform engineering movement was really coming up with an answer. Platforms is the flip side of cooperative delivery. How do we achieve cooperative delivery, including our app team and our infrastructure team, with a platform, with a shared platform that makes it easy for application delivery folks, application teams to deliver. So we renamed the group the Platforms Working Group, and we set out to write this paper. A bunch of us got together at KubeCon Detroit last October, and so we're gonna put together a definition, vendor neutral, very technical, in support of, our first goal was to support engineer architects, people that want to advocate for platform engineering within their company, how they're going to convince their director or their VP, this is going to have an ROI for our product, for our company, it's worth investing in. That's kind of what our first paper takes, that perspective, and says, here's strategically why you want to adopt this platform mentality and adopt platform engineering. We continue to work on this. So if you want to join us, we continue now, especially we're working on tactics now. We've kind of, to some degree, if you read the paper, maybe you'll be convinced. We've convinced a lot of people that it is a strategically good direction. Now they're asking us, okay, help us on this journey. What does it look like? How do I go from my classic data centers to a more platform engineering, agile environment? Anyway, one of the big things we defined, one of the big debates we had at the beginning actually was, what do we call these platforms? Literally, some people want to call it developer platform, delivery platform, DevOps platform. I saw Gartner, they just published a report this week or last week about DevOps platforms, but they used to call them value stream delivery platforms, which is very accurate, but also very arcane, and nobody knows what that means. Anyway, so we realized we're not going to be able to choose an adjective. So we just said, we're going to define what a platform is in general. Two major things. One is that we said a platform is when you're bringing together a bunch of capabilities with a consistent experience. So, for example, when this comes up in cloud native computing is like, we tried to list out, but 10 different categories of capabilities that you might need to run a cloud native environment. And we're trying to point out like, hey, if you don't think about this deliberately, you're going to end up with 10 different patterns. My database, I get this way. I already open a service now ticket and talk to that guy. My IAM roles, I talk to this team. My DevOps pipelines, I talk to this team. If you don't try to put a consistent layer over the top of that, it's going to be not great for your app dev team. We also called out that it's to target a specific need. Rather than just the generic platform that can cover anything, it should be built towards the needs of, if it's application development, web app development, backend development, ML ops development. Yeah, so check out the paper. There's the slide up there. I don't have a clock here, so I want to make sure that I'm on track. You know what? Okay. I think it's important to mention this, that there's always a platform. There's always this abstraction somewhere. It's really a question of where is the right line for your organization or your environment. And it kind of takes building up, to be honest. Like, even I'll talk about here, you could build a Kubernetes platform and you could build, more layers on top of that. But I think it's relevant to say, like, from the, there's probably a bigger gap here. I skipped some, but we started out, you want to program an application, you want to program a workload, you had to have somebody go in and plug in different patch cables. Eventually that all got abstracted away by an operating system, which lets me use kind of generic hardware and reprogram it, just by writing code. So, back in the 2000s, 1990s, we had data centers full of servers, which were abstracted by the operating system. As we get into like the late 2000s, 2010s, that gets kind of abstracted, kind of the VMware, AWS EC2 era, where we're no longer really looking at our servers anymore. What are we providing to our, and I put app developers, because this is what we're delivering to app developers. So like in 2005, I was working at a company, they gave us 20 hardware servers, we run our SharePoint farm on. In 2015, they would give you 20 VMs. Or 20 EC2 instances and some buckets and virtual networks. Where we're going now is platform capabilities. Like, great, you can give me compute, storage, and network. Now build a database out of them. I don't have time to do that. Build a certificate manager. This is SQS. I wrote down what each one is. ROSA. This is ROSA, actually. They have the first class icon for OpenShift. That's the whole OpenShift. These are different managed code build, so different managed capabilities or platform capabilities that our AWS gives. And most of the time, your app developers are not getting down to this level anymore. Maybe some. The truth is that nothing ever goes completely away. So they might still be using infrastructure also, and they might even be using servers, but a lot of use cases can be met by just giving the platform capabilities. Yeah, another topic that came up in the discussion as you're writing this paper is the term internal platforms. If you've heard, who here is sort of internal developer platforms? That term has been making the rounds, the past year or so. And we wanted to be really deliberate, like, why are we calling it a developer platform, internal platform? We did agree, we had some debate, but we said, okay, internal platform is a valuable term, and that's the reason why in that subtitle, no more, no less than your use cases. This is like, it just seems worth mentioning. You need to be meeting the use cases. Like, you're trying to build web apps, then you need to provide web apps. You need to provide the capabilities to build web apps. You're trying to let people run COTS, commercial off-the-shelf applications, third-party applications, then you need to think about that. You want to enable people to do data science and ML ops. Think about that. What does your enterprise need? So no less than what your enterprise needs. And believe me, I've talked to customers who are struggling. Their IT teams struggle to know what their app dev teams need. So that's an important part. Like, this is an internal platform. You got to cater to your internal needs. And also know more. We thought that was worth calling out. Like, there are companies like Spotify or the folks that did Argo that open source, and they try to cater to the industry-wide need, but that should be a non-goal for most of us. Focus on meeting the needs of your enterprise. We tried to delineate, on the why. This is what I was saying before, the business case that you could build up. Reduce the cognitive load is a term that people know from many industries, so it resonates with folks. Basically, your app developers have to know too much these days. So by moving some of that stuff into a cross-cutting platform team, you're making their lives easier. They can be more productive. By moving them, like if a classic DevOps arrangement might have a different DevOps person in 10 different product teams, each doing things slightly differently. You want to improve reliability and resiliency of those capabilities, start to put them into a shared team, start to let them create common patterns across the enterprise. That's also will reduce risk. But then a really important one that's been coming out as I talk to people is when you are owning your platform, even if that just means the top layer of it, it makes it easier to bring in managed services. Folks here, maybe you're all in on AWS, and then maybe this isn't a concern. AWS is your platform, basically. But if you're, kind of bringing together multiple SaaS, software and service providers, cloud providers, if you don't put a layer over each one, it's going to look different, and you're going to surface that complexity up to your dev teams, and they're going to end up with a million different patterns for integrating. So bringing in managed services, if you can bring them into your thinnest viable platform. Sorry, I use that term. And I used to have a graphic here that kind of illustrated that. There is a term from some folks out there, thinnest viable platform, and that can kind of you can keep that in mind. Like, how much can I delegate to a managed service like AWS or to a managed software provider like Red Hat, and not have to create myself? So I just have to own the top layer and a little bit down into it, but not too much further. The last thing I wanted to say, and then I'm going to do some demos about ROSA and all that, is why. Why is this coming out now? Like, why wasn't it 10 years ago that we said you need a platform engineering team, or your DevOps team is burnt out? Some people express it that way. And I think this kind of illustrates it. So this is an app I built this like 5 or 6 years ago, actually. And it's not even that complicated of an app. It's just got 2 microservices, a web front end, running some JavaScript. But it's all distributed. These are microservices that could be scaled up and down, and that one's another one. But then I need a database, and it's not in a server that my infrastructure team has given to me. It's some API out there. It's Aurora, it's RDS, it's something out. Same thing with Cache and Plum. I want to shut something off via a queue to some sort of function. I want to make sure everything is observed by some collector and then analyzed in some dashboards. I didn't even get into what the developer side needs, a code editor, fine, maybe that's on their desktop, but where do they store their source, the Git repos? Where do they store their artifacts, their built images and things? So there's all these, we're building distributed apps, and at this point, we kind of need distributed capabilities to go along with that. So I think it's the evolution of cloud native architecture, distributed architecture, which is kind of leading to this need for a team to manage this. What I'd like to do, I didn't get around to it yet, is to kind of draw arrows from each of these. Like, basically, in each of these things can fulfill one of the needs I have up here. Yeah. And so these were, actually, we're trying to kind of suss this out now in my group at Tag App Delivery. We'd love to hear, by the way, if you want to ever come to, we meet every other week, every week, even if you want to come and tell your platform story, we'd love to hear it. These are some of we put in the paper a list, again, we say internal platform, what you need is what comes first. So don't just pick our list, but this could give some guidance on capabilities your developers might need. Okay, so now I kind of set the stage for what a platform is. Now I want to show how ROSA, Kubernetes, OpenShift are a great way to build this kind of a portable, this kind of a platform. And what stands out, and that's why I said portable, is that's probably the main difference between, say, taking AWS all in as a platform, which at AWS conference, if you want to do that, okay. But if you're looking for a portable platform that you can run on-prem, that you can run in other clouds, you know, that you might, yeah, it might not be all AWS. Yeah, so let's talk about what ROSA is. First of all, I hope everyone knows, but not everyone always knows that OpenShift is to Kubernetes, kind of how RHEL, Red Hat Enterprise Linux, is to Linux. It's, you know, a downstream, packaging it up, adding functionality, supported for a longer life cycle, making sure CVEs are addressed, you know, all kinds of extra kernel level stuff. That's kind of what it is. So OpenShift is Kubernetes. But it's a lot more than that. But I don't want to miss that. It's also Kubernetes. And I even put, like, in my abstract for this talk, like EKS versus ROSA, where you might use it. Like EKS is really about just Kubernetes, whereas ROSA would and that's what I'm going to get into, lets you kind of leverage Kubernetes to build a platform. I kind of see EKS as like, okay, that's my container orchestrator within my greater AWS platform. But if you want to use Kubernetes as your platform for platforms, then OpenShift can be a big aid. And I'll show you what I mean, actually. That's the third bullet point here. A really good part about having OpenShift in AWS and how they complement each other really well is the scalability. So do you want to maybe close that door? Yeah, thank you. So like if you want to run OpenShift on bare metal and you install Kafka, let's say, the Kafka operator, and it needs a lot of resources and it needs new nodes, scaling that stuff up quickly is a pain. I mean, it's impossible. What are you going to add? It's going to take forever. You're going to add a new node. The great thing about AWS, and I'm going to show you this, I just click machine set, add me another machine, or I can even auto scale. This happens to me all the time. I run out of space in my cluster, spins up another machine. Of course, I can also, you know, instantly spin up the same cluster in another AWS region. And I won't even mention what I said. You could run, we have equivalent services in Azure and Google too, if you wanted to. The operators part is, operators is kind of what Red Hat uses to describe Kubernetes extensions. It's a way to add more functionality. So like out of the box, if you have people here work with Kubernetes to some degree, who here has worked with Kubernetes? Let's put it that way. Okay, so Kubernetes has some core IaaS concepts, like you want to deploy a container in Kubernetes. It's called a pod. It's a collection of containers, but it's basically, you know, a descriptor to run a container. You want to set up a reverse proxy, a load balancer across several, you know, pods, several containers. You set up a service, and that basically aggregates them all behind one name. You want to set up a way for that service to actually talk to the internet. You set up an ingress, or in OpenShift we call it a route. So that, and you want a volume, you want some disk. It's a persistent volume. You can create one of those. But then you want a database. You want a container registry. You want a pipelines infrastructure. That's the kind of stuff that operators and extensions to Kubernetes can add. I'm going to show you that. Like, and that's actually ROSA is really good at. There's like 300, 400 first party and third party and custom operators that extend that same Kubernetes API, that same platform into higher level stuff. So that's kind of platform capabilities, Red Hat and partners. Actually, I'm going to show you also, there's one called the AWS controllers for Kubernetes, which projects AWS resources like S3 buckets and EC2 instances straight through the OpenShift APIs as well. So it can go that far. I also like to point this out. Like I said before, like OpenShift is to Kubernetes, like RHEL is to Linux. Red Hat is really good at kernel stuff. And so if you need to you know, support a new GPU or support a different driver or pin CPUs to a certain workload, or add a kernel module to every node, stuff like that, we've got some really good tools for that. So yeah, I kind of think, yeah, the advantages of OpenShift are kind of at that low level and then at that platform level. Another one, and this last one, familiar UI, UX, it's the kind of thing like as an engineer, you notice last, I guess, but it's one of the benefits, it's one of the things that people call out to us. You get the same consistent UI. You get a UI because Kubernetes doesn't come with one. In every place you're running OpenShift. So that's nice. And I also am going to show you a backstage-based UI that we're working on. Okay, so, oh my gosh, it's 11:52 already. Well, I'm going to walk through this pretty quickly, so it's okay. I want to show I'm going to make this big. I'm going to show you, so it says in that slide, let's just bring that up, what I want to show you. I'm going to just quickly create a Kubernetes thing so you'll know what it looks like. I want to show you some of the higher level capabilities that operators give you. I'm going to quickly show you what a machine set looks like. I'm not going to actually show the AWS controllers Kubernetes working, but I'll point them out. And then if we have time, the last thing is to actually show a Spring Boot service deployed on this portable platform. So let's go over here. This is what we call the hybrid cloud console. And so it's just console.redhat.com/OpenShift. I get a list of my clusters. I actually have two. ROSA, that's a totally managed cluster, SRE managed. They've got some extra bits into there. This is a self-managed one that I've deployed myself. Sometimes I want to get to the lower level stuff that ROSA doesn't always allow. I can hit ROSA 2. And probably what I would usually do is just open console. This is always the moment of truth where I pray everything is still running. And it is, I think. Come on, baby. That will, yeah, there it turns green. I just want to show you really quick what it would look like to create the simple things in Kubernetes. And because like I said, I think people appreciate this about OpenShift. So I'm just going to create HTTP server. What I do is I create a project, which is kind of my tenant space in the cluster. It actually maps to a namespace if you know how Kubernetes works. Underneath that, I'm going to create a deployment. Nice thing about OpenShift is a lot of the stuff has a form field, which is basically just the YAML. It's a special annotation that says, hey, put this in a field like this. And name it there, and then that makes sure that it's all named properly back here. Just gonna say HTTPD. So now this is my compute. I need to load balance those things, so I do that by putting it behind a service. This one does not have a form, so I just have to do it manually, but that's okay. Basically, this says which a service is a reverse proxy against those pods, and it says look for all pods with this selector, and oops, that's not and send traffic. It comes into this at port 80, so I'll see that. And then finally, I just need to create a route to the internet. Again, I'll just call it HTTPD. This is kind of cool. So I choose that service that I made. I say I want to hit that port, and I can instantly, this is a nice thing in OpenShift, I can just right away say, okay, add TLS termination, redirect, I hit create, the route's coming out, hopefully it's up, and there we go, and the service is up and running. So it's a nice way to get started with Kubernetes. You know, I can get rid of that now by just deleting the project, but I won't bother. Now I wanted to show the advanced capabilities with operators. So there's two places that are most relevant in this console. One is API Explorer. So remember, I described a platform should give a consistent interface for all kinds of things. Here's where you can find your stuff. So I've actually installed, for example, the Mongo operator so that I can get a Mongo database on demand. I've installed, it's called, the name of the resource is cluster, unfortunately, but it's kind of confusing. But here's my Postgres cluster. So I can install a Postgres cluster on demand. I always have to do that. I've got other things like a Quay registry. That's a fun one. Oops. Quay registry. And I can just declare a Quay registry. I actually have a Quay registry running in this cluster, I think. I can create a Jaeger. That's a telemetry trace system, et cetera, et cetera. So I can do that. API Explorer. Not saying this is necessarily the end interface you want to give to your app devs, but it's getting there. And this can be the point of compatibility. Operator Hub is where those things are actually coming from. So operators are that was the API. Operators are the actual implementations. So like when I declare a MongoDB thing, then it's actually going to find, the MongoDB operator in here. I think I'm using the community one. And that's going to do the work of creating it. I'm going to just show quickly here. So I mentioned, here's the Red Hat ones. There are tons of first-party services like pipelines and GitOps and things like that, which I've already installed. Then certified is a lot of our partners, so things like Redis, AppDynamics. And then there's also community And marketplace are ways, that's a way you can pay for it through IBM. So some of them are paid. That's marketplace. What was the next thing? Yeah, so that's a higher level capabilities. And I want to show, hopefully we'll get to it, the Spring API server actually uses, it's just a bunch of files and it describes the different custom resources I'm going to use. The next thing I wanted to show, I mentioned that machine sets, which I think is super cool. So machine sets here, I actually, in this, I have to control it back through this console. You see it says machine pools. So let's say by default right now, I've got a machine pool. It's saying I got 2 to 10. I was able to do this all in the console. So it scales up when I run out of nodes. Here I have another one that's I'm able to manually scale even. And I can just hit 4. And momentarily, you'll see the machine set in my cluster. Yeah, you see it says 3 of 4 machines down there. So now one of them is coming up, which is really nice for me at least. So I can quickly get the resources I need. I did want to show the ACK, the AWS controllers for Kubernetes, since this is AWS, and this is, a lot of my customers ask about this. It's a whole set of controllers that let you have Kubernetes descriptors, Kubernetes manifests for AWS things. So like, yeah, I have ACM, I'm not that familiar with, but there's DynamoDB, EC2, S3, everything you want in there. You can even set it up to work with IAM roles so that you have an account that automatically can create things in the right way. Okay, before we wrap, I do want to show you the end result of all this. So like the end result of all this is to serve our app developers, right? So if we go to GitHub, Josh Gav, here is a Spring API server, which is ready to be deployed on any of my clusters. And I'll just show you the core of it really is this base folder. And this is not a very complicated app. I just didn't have time to make it that complicated. But there's a deployment where I deploy a pod with my built Spring service in there. Here's an instrumentation, which allows me to instrument it automatically with OpenTelemetry. I've added all these capabilities to my cluster already. That's kind of what, so till this point, I was talking about how you build a cluster or how you build a platform with all the capabilities. Now I've switched over to the app dev persona who's using my cluster. And this is what the experience, at least the basics, like I said, you could build further on this, but this is a base experience for them. Here's my PGDB, that's the Postgres cluster, pretty simple. Here's the route, that's the ingress, service monitor, which is a Prometheus thing. And then all of that, I've got a pipeline defined here. This is on PR and on pushes. And then at the end of the day, once that pipeline runs, I get, let's do it from OpenShift on AWS. I get my pods running here in Spring API server. And I will have a route for them here, and I can click and go check it out. That one just says hello world, but I actually have it working with the database, returning widgets. So there it is running. The last bit to show is that the last element I would say in a platform is helping your app devs get a view on what's happening with what they've deployed into the platform. That's what we're beginning to call portals. Who here is sort of Backstage? Anyone heard of Backstage? That's a popular project in CNCF right now from Spotify originally. And that's what this is. Red Hat's building something around this called Developer Hub. And this is a single place where developers can come in and see things related to their application. This is not so complete, but at least you can see my GitOps process, my pipeline run. Here's the last bunch of pipeline runs. Here's my registry. Here's even a little bit, not the best filtering right now, but it's got the actual pods that are running. It can pull in docs. Another big thing about Backstage people like is you can also create templates that will create new projects for yourself, like create a Spring Boot backend with a CI pipeline. So that's kind of the, let me go back to the deck now, we're about done. That was deploy a Spring Boot service using the platform. And then Yeah, and so, yeah, that's it. I wanted to put up the product page. You can go try out ROSA within the AWS console or the Red Hat console. I actually wrote a post like a year ago with not just ROSA, but 2 or 3 other ways to deploy Kubernetes and OpenShift and AWS. So check that out. Yeah, and I'm around. And if you want to talk Kubernetes, CNCF, Red Hat,